Today we're going to be talking about inverse relations and functions. And you dealt with this in Algebra 2, but we're going to revisit it because it's an important theme throughout the entire year. So first we're going to talk about this graphically. So the first two things graphically is a function. If we have a function and we want to graph its relation, we can switch the x and y values and plot the new points. If we switch x and y, that means the domain and range are switched. By switching the x and y values, this last point is true, that a function and its inverse are symmetric to the line y equals x. So let's do an example. So we're going to graph f of x equals x minus 1 squared plus 2 and its inverse. Now this is an equation that you should be able to graph without a calculator. It's a parabola y equals x squared. It's moved to the right 1 and up 2. So I'm going to start my graph right 1, up 2, and then I'm just going to go over 1 and up 1, over 1 and up 1. And there's my parabola. So this is f of x. What I can do is switch the x and y coordinates. So those three coordinates that I plotted, we were at 0, 3. This point was at 1, 2. And then we were at the point 2, 3. So for the inverse, I'm going to switch that. I'm just going to take these numbers and swap them. So 3, 0, 2, 1, and 3, 2. So we'll graph these new points for the inverse. So the point 3, 0, the point 2, 1, and the point 3, 2. So this graph looks like this. Couple of things. First, if I were to draw the line y equals x in here, okay, we can see that they are clearly symmetric. The other thing is that this inverse is not a function. It does not pass the vertical line test. So it does have an inverse, but this inverse is not a function. So we'll do another one of these. So now we're going to graph the line f of x equals 2x minus 1 and its inverse. So 2x minus 1 has a y-intercept at -1, and then it has a slope of 2. Okay, then for our inverse, we'll switch the x and y coordinates. So the point 0, -1 is now going to be at -1, 0. This point at 1, 1 will be at 1, 1. And then this next one is at 2 and 3. So then we'll go 3 and 2. And that's enough to show us our inverse. Now that one is a function. So let's talk about inverse functions. First, some notation. Okay, the inverse notation is going to be an f and then a little -1 of x. That's indicating that we have an inverse, and that inverse is a function. It is the inverse of f. This does not equal 1 over f of x. Okay, so that's important to note, that this -1, although as an exponent something to the -1 would be 1 over that, this is not. In order for a graph to have an inverse that is in fact a function, the original graph must pass what's called a horizontal line test. So let's take a look at these three graphs. Okay, horizontal line test, just like a vertical line test, we're looking for, does it touch at more than one spot? And if it does not pass. So that one does not pass. The second one does, so that would have an inverse that is a function. This one does here, but as soon as we get to this middle part, it no longer passes. So this is if the inverse is a function. Another name for that is one-to-one. So if a function passes a horizontal line test, the original and the inverse are what's called one-to-one. That for any x value, there is one and exactly one y value. Versus here, there are values that share different y values. Now we're going to look at inverses algebraically. So we're going to find the inverse function. So we're going to be finding the inverse function. So first we'll check to see if the function inverse even exists. So we're going to see if it's one-to-one by seeing if it passes a horizontal line test, and we're going to do that by the graph. If there is in fact an inverse function, then we can find it, and our next step is going to be to let f of x equal y. Then we're going to switch x and y and solve for y. Then once we have solved for y, we'll let y equal the inverse. All right, this is a wordy one. So our example is to determine whether each function has an inverse function. If it does, we'll find the inverse and state any restrictions on the domain. So our first one we're going to do is f of x equals x over 2x minus 1. And if we don't know what a graph looks like, we can use our calculator. So if I graph x over 2x minus 1, we can go ahead and just graph this on a standard window. So zoom standard, and if we want to adjust the window, we can. Okay. So let me zoom in just a little bit. So I'll just do a zoom in. That makes life easy. Just to see our graph a little bit better. And there we are at. Okay, so this graph, okay, has a horizontal asymptote and a vertical asymptote. At every other location it's defined, and if we look at the horizontal line test, it does in fact pass that. So there is an inverse function. The domain of this graph is the set of x values. So our domain is going to be anything unless x equals, in this case, 1/2. Okay, and then the range is all the y values, and that's another 1/2. So as long as y does not equal 1/2, then we're fine. That will come into play at the end of this when we state restrictions on the domain. So I'll come back to this part. Now we're going to find the inverse function. So we're gonna picture this as being a y, and then I'm gonna switch all the x's and y's. So this is gonna be x equals y over 2y minus 1. That's the inverse, but it's not solved for the variable that we want it solved for. So we need to solve this for y. So first thing I'm gonna do is multiply that denominator over. Then we're going to distribute. So 2xy minus x equals y. I'm going to move everything that has a y to one side and everything that doesn't to the other side. So I'm going to subtract a y and I'm going to add that x over. Now I can factor out a y. And then I just have one y left, so I can divide. And this would be my inverse function. That would be our function and any restrictions on the domain. So this one's a little bit funny just because the domain and range are the same, but the domain and range of the new function are switched. So this is your new domain. The old range is the new domain. So this function is fine as long as x doesn't equal 1/2. Now this one's kind of funny because the function and its inverse actually ended up being the same exact thing. That's unique, but can happen. All right, so we're going to do another one of these. So same question with f of x equals 2 times root x minus 1. So if I were to graph this, and you can graph it on the calculator, but this is one of our parent functions that you should know. It's going to be our square root, move to the right 1, and stretch vertically by a factor of 2. So the next one, rather than being over 1 and up 1, would be over 1 and up 2. And we'll just go with that. So this one, again, has an inverse function because there is no issues here. If you have a problem in your homework and the original graph doesn't pass the horizontal line test, then you stop there. But this one does, so we will do the rest of this work. The domain here is x is greater than or equal to 1. It's the y values. My range is my y values, which is going to be greater than or equal to 1. So now we'll find the inverse. So I'm going to let x equal to root y minus 1. So we'll divide by 2. Square both sides. And then add 1 over. So my inverse function is x over 2 squared plus 1. But we have to restrict the domain, because if I were to graph this parabola, it's not going to look like this. It's going to be the whole parabola. So the inverse function is only for the values that match this graph. So again, we're going to use this. This is our new range. So this graph works as long as x is greater than or equal to 1. If x is less than 1, then the inverse doesn't match up with our original graph. This last one, x squared minus 1, so same directions. If I were to graph that, just do a quick sketch, it's going to be a parabola like that, which does not pass the horizontal line test, so this does not have an inverse function. Next, we're going to talk about the formal definition of an inverse. F of x and g of x are inverses if and only if the following thing is true: that the composition of f of g of x and g of f of x is x. If we do the composition, they basically undo each other, then the inverses, the functions are inverses. If that's not true, then they are not. So we're going to verify that f of x and g of x are inverses. And our first one, f of x equals 3x squared plus 7. There is a restriction that x is greater than 0, so this would be a parabola. This is just half of the parabola. And g of x equals the square root of x minus 7 over 3. So we're going to look first at f of g of x. Okay, so this is going to be f of this whole thing, root x minus 7 over 3. So now I'm evaluating this function here. So I'm going to take this entire thing and plug it in for that x. So we're going to have 3. Instead of x squared, we're going to have root x minus 7 over 3 squared. And then we just start simplifying. So first thing, the square root and the squared cancel. Okay, then the 3 times the 3. Oops, sorry, I forgot my plus 7 here. So it's 3x squared plus 7. Plus 7. So the 3's cancel. And then the 7's cancel. So we're left with x, which is a good start. But we need to do the same thing the other direction. So we're going to do g of f of x. So that's going to be g of 3x squared plus 7. Okay, let me slide this over out of that bright light. So I'm going to take this and plug it in for the x in g. So instead of x minus 7, we have 3x squared plus 7 minus 7. The plus 7 minus 7 cancel. The 3's reduce. And then we have the square root of x squared, which is x, which does in fact check out. So these two are inverses. Okay, so next problem, f of x is 2/3 x plus 2, and g of x is 3/2 x minus 3. So we'll do the composition, f of g. So that's going to be f of, I'm taking this whole thing, 3/2 x minus 3. And I'm taking that and I'm plugging it into this. So we're going to have 2/3 x, which is getting replaced with this, plus 2. So we'll distribute here. So 2/3 times 3/2 is just 1. 2/3 times a negative 3 is a negative 2, which gives us x, which is a good start. G of f of x is going to be g of 2/3 x plus 2. So we're going to take this whole thing and plug it in for that x. So 3/2 times 2/3 is 1 again. 3/2 times 2 is 3, and I again forgot my minus 3, minus 3. That gives me x. So these are again inverses. And that is all about inverse relations and functions.